Oh, there it goes. Cool. Sorry. Okay, rock and roll. All right. Well, hi everyone, and welcome to our second guided project for blockchain. So what I want to do tonight is do a quick little review of what we did last time, kind of review where we are in the big picture of blockchain, and then we're going to go through the client mining project. So if you got stuck on that, no worries. Ask questions as we go through that. And then we'll go on and add to our project. We're going to give ourselves the ability to add a transaction. Yeah. So that's the agenda for tonight. So let's start off with a little review of where we were the other day. I'm going to share this. Great. Okay, so hopefully you now see this little illustration of how blockchains work. It's kind of simplistic, but I just want to situate us within the the big picture of how the blockchain works. So we know a transaction will be requested. We have not yet implemented the part about a transaction being requested. A block that represents the transaction is created at step 2. And this block, as we know, is a bunch of data that we're going to send out. And the block is sent to every node in the network. Or if it's a Genesis block, we're just going to create that. Nodes validate the transaction. They'll receive a reward for proof of work. The block is added to the existing blockchain, and we're done. So that's another way of putting what we're trying to do here, or what we're working on doing, what we're building up to. Let me now switch to, so what did we accomplish last time is really what I'm working up to doing here. And I can look at our file that we worked on in the last class. So in that big picture of blockchain, what functions did we manage to implement last time? Let me look at this. Ooh, there we are. So if I go down, so last time we had this, we built this blockchain.py file with a couple of routes. We had mine, we had chain. I'm actually going to delete these 2 lines here. I think those are useless. So one of the things that we didn't do last time, and we're going to return to at the end of today, is we didn't do much with transactions. We had this self.current transactions. We haven't really done much with that. What we did focus on was adding a block. We hashed a block, we added a block, and then we came down here and we saw this proof, and we worked on this proof of work and valid proof methods. So, okay, I still want to keep going on this theme of, how does this relate to blockchain in general? But let me first give you all a quick poll. I'm curious to know how far you got with the client mining project. Are you completely stuck? Did you do the server part, the server and miner part? Are you pretty much finished? You're somewhere in the middle. Or are you, as I say, pretty much stuck? So I'm making this an anonymous poll. I send it to the channel just to get a feel for where everyone is in this. Okay, so I've got, people are still trickling in and voting, but so far we've got, a split. We've got a few folks that were able to pretty much finish it, and some people are like still in the middle. Some are just more in a place of feeling, hey, I'm just kind of stuck here. I don't know what to do. So wherever you are, we're going to go through this together. But here's a question for you. Why are we trying to, what's the point of this client mining project? Why are we trying to split it up? What do we hope to accomplish? Yeah, we don't want to mine on the server. We want to have as many clients mining as possible. In the real world of blockchain, let me stop my share real quick since I'm not really doing anything with that screen. In the real world of blockchain, if you will, some people are just devoted to mining, and then others may be running what's called like a full node that will check and validate transactions. So not everyone is running the full node all the time. Some are just dedicated to mining. Some might just be validating and checking. So we're kind of mimicking that, and we're setting ourselves up for a project where we can have one server working with multiple miners. So that's what we're going for. You can have multiple people running miner.py and maybe one person running blockchain.py. And so we're giving ourselves the ability to set up this network where we're all working with the same server, essentially. Yeah. Actually, let me go back to my editor. I kind of want to check our understanding here. So when we run this file, when we run this Flask app, and we run mine. So mine runs proof of work, we run previous hash, we run new block. Where are we at this point? If you're visualizing, imagine the whole chain, right, linked together. Where are we now? What is this going to do when we're done? Yeah, absolutely. We're going to lengthen our chain by 1. We're going to add a new block, forge a new block in our chain. And when do we want to do that? What's the trigger? How do we know, hey, it's time to add a new block? So we come down to like line 150 here, and we're like, oh, we're going to call new block. Yeah, if the proof is valid, that's when we know. And so we can do the mining here, and then we know, and then the proof of work is already checked that this is a valid block, so we know to add it. But we don't have to do the work. We could just validate it. So if we've got our valid proof, then we know we can add a new block. We're ready to go. Cool. All right. So at this point, let's start working on client mining. So let's discuss the homework that we were going to do. So if we open up client mining, I'm actually going to, let me share this screen here. So our task list was to remove the proof of work function from the server, change valid proof to require 6 leading zeros, and so on and so forth. So we already know the purpose of this. So I'm going to kind of copy and paste this task list because sharing multiple applications here does not work well for me, I'm sad to say. Okay, I think y'all can still see my editor, right? Excellent. I changed the screen, so I wanted to be sure. Right. So let's do this. Remove the proof of work function from the server. Where should we put this? If we're gonna, what should we do? Should we, with proof of work and valid proof? Where should this move to? Yeah, it should move to the client. It should move to our miner, essentially. So if I scroll down and copy this, and then I'm going to open, oops. Oh, well, first, I forgot. I am still in the basic block folder. So I'm going to copy and paste all of this into our client mining blockchain folder. So paste it here. Got it. I have pasted it. And then I'm going to scroll back up and, as directed, we're going to go into miner.py and essentially we want to move these things over. However, so okay, I'm copying and pasting. What do I need to do to make this work in this file? Besides indenting. So if we copy and paste, you know, and everyone does it sometimes, but it's not really best practice because it can introduce hard to spot errors. What errors can you spot right off the bat? Aha, thanks for saying that, Lorenz. How's that? Hopefully it's much larger. Great, okay. Well, I can spot that we, for instance, have left self in here. So if we're going to use this, like self.lastBlock, that's only going to work inside of a class. And these are no longer in a class. I'm going to leave a to-do here for us. Let's go back and keep working on our blockchain file. So the first step was to remove proof of work. So we copied those over into the client, and now we can safely remove proof of work from our blockchain.py and client mining. And let's see, what's our second step? I have the task list up in front of me on another window. It says change valid proof to require 6 leading zeros. Okay, that's also pretty easy. I'm going to kind of zip through this. I think y'all probably are able to do these first steps pretty easily. Add an endpoint called last block that returns the last block in the chain. Great. Okay, so how should I add this endpoint? Add an endpoint called last block that returns the last block in the chain. I heard that some of y'all were having some issues with Flask. So I'm wondering if this is like where you had questions, where you got stuck. Regardless whether you got stuck. Anyone know how to add an endpoint? Yeah, we want to do a Flask route. So we can copy the pattern below. We can do app.route. We want to call it last block. Should this be a get or a post? Single so it matches the others. Yeah, I'm gonna, exactly as Reed put it, methods equals get, and then we can do, say, def last block. And what should this return? If we're trying to return the last block in the chain. Yes, first of all, how should we get the last block in the chain? Yeah. Yeah, I think, so, Miguel suggests getting self.chain -1, and Reed points out there is a method on the blockchain class. So we've actually made this, if I scroll up to look at this, we've actually made this a property. So we don't even have to call it, we can just access it as in blockchain.lastBlock. So we could do it we could do it either way. Do last block equals blockchain.chain -1. That'll work. We can also take advantage of our property up there like that. Yeah. Okay. And what should we return? I'm going to scroll down so you can see the other Flask routes. What will happen if we just return last block? Yeah. Yeah. So, yeah, totally right. Reed's right. We need to do JSONify. So with, Flask has this syntax here. So we're going to need to have a response and then JSONify it. And then Flask will take care of adding the correct headers. JSONify will, turn this object into JSON, and then we'll add the correct headers so that we can send this via our API. We have to send a response. We can call it, say, have a property last block with the value of the last block. And then just as below, we want to return that response JSONified with 200. Okay, not too bad. let's see. The next step on our task list is to modify the mine endpoint to instead receive, invalidate, or reject a new proof by a client. It should accept a post. Use data equals request.getJSON to pull the data out of the post. And note that requests and requests both exist in this project. Okay, so that's kind of a lot. We want to come down here and modify mine. It tells us right up front this is going to be a post method, like so. And as we just discussed, we know we want to add a new block after we have validated, after we know that we have a new proof. So we don't want to run proof of work ourselves because, for one thing, we just deleted that from this file, and so it's not going to work anymore. Instead, we want to receive and validate or reject a new proof sent by a client. So use data equals request.getJSON to pull the data out of the post. So that is just, I'm just going to copy that over like that. So that when our client hits this, then we should now have a nice object in data. And that's just a bit of how Flask works. Then it says, check that proof and ID are present. Okay. So this data object should contain a proof, which we're going to check, and an ID, which we won't use yet, but we will right after we finish doing this client mining. So how should I check that those are present? I guess, and what should I do if they're not present? Or let me put it another way. Suppose a client sends some data. So they hit our endpoint mine with a post request, but the data they send is just an empty object. It does not have a proof property with some, proof here, like it should. What's going to happen in Python if I say proof equals data proof, but there is no proof property? The client has failed us. Yeah, we'll get an error and shut down. The server will immediately crash because this, again, Flask is a very lightweight server. So this will cause a crash. How can I check if proof is in this data object? Anyone remember in Python? I know you have to switch between JavaScript and Python pretty often. I believe, yeah, good suggestion, Adam. I think I did try. I recently tried in Python if proof is not none. But at this point, I've already hit an error. And I think I would also get the error if I just tried to do data proof here as well. Like that would also give me an error because I'm trying to access the key. So I just tried that earlier. I thought, oh, maybe this will work. Of course, in JavaScript, it would just be undefined. And so, you can do this. It won't actually throw an error at that point. One of those gotchas when we're switching languages. Yeah, Yasira's got it. We can say if key, so it's like if key in dictionary is the syntax, if proof in data. Or here, I guess we want to check if it's not there. So we can say if proof not in data, then we want to handle that. So we could say a response would be message acquired property, for instance. And then we would return JSONify response. We copy and paste that. Should it be a 200? What should we send back? Yeah, 400. This was not a successful request. So let them know that. Cool. Okay, so we're checking that proof is present. We can also check for ID or ID not in data. Now we're checking that proof and data are both present. And if they are, so now we know they're present, we're safe to go ahead and pull them out into a variable so that we can use it. Oops. Like that. Do minor ID equals data ID. Okay. Now, how should we validate this proof? What do we do to check that this? So before we knew what proof we had. But here we've just been sent a proof. We'll run the validity. And let me scroll back up and look at this. So the valid proof, it wants a block string and it wants a proof. Okay. So we're going to run that. So we're going to run blockchain.valid proof, and we're going to give it a block string and a proof. But we haven't yet made the block string. How do we stringify this block? Yeah. Yes. And we can come back to, I was going to say something about that, but I'm going to drive on right now. Yes, good question. So let me make the block string real quick. Block string equals JSON.dumps. What do we want to do here? Which block do we want to pass in? Yeah, the last block. Oops. Blockchain.last block, and sort keys equals true. Again, I think I don't have to say sort keys because this is Python 3, and it will do that automatically. So so Adam, raises a good question. Wait, haven't we already checked that this is a valid proof? Well, the answer is maybe someone else has done this mining. So I'm running this blockchain.py, and someone else, say Adam, is running miner.py. And then, so Adam, you send to me the proof you found. You say, here you go. I already validated this proof. But, as they say, trust but verify, to quote Ronald Reagan. So I have to verify, because otherwise exactly. This is blockchain world. In blockchain world, we don't trust anyone for anything. We check everything using cryptography. Okay. So blockchain.valid proof will return true or false. I'm gonna go slow and let people ask questions as I go. I do have some simple diagrams to talk through later. Okay, these are great points. So yes to Arpita. So the server is going to validate here all the time. So suppose, let me see here. Hang on, let me try this. No, wait, I want, aha, okay. I have found the annotation tool. Here is our server. And someone else is running miner.py. Yasira is running miner.py. And so when Yasira, sends a proof to the server, and it's a good proof, we have our little Genesis block here, G, and so we add that proof. It was a valid proof. And so Yasira's block here gets entered. Meanwhile, I am also over here mining away. And maybe I see that, hopefully I see that Yasira has won the contest. I get that block and I start working on it. And I'm running my proof of work and validator, right? I have proof of work. I have my validator who works with my proof of work. The server is also going to validate because, they don't trust us. They need to know this is valid. And suppose I win the next contest. Now, if Yasira then wins, so she mines faster and she gets this block. If I don't see that, if I don't get her block, she went. So we're both mining, and we're mining at the same time. She sends hers to the server, and it gets validated and gets added. 3 seconds later, I send mine to the server. I was pretty quick. I almost made it. But which block was I working on? Which block was I using with my proof of work function? Yeah, I still am working with this block. And so my proof is for this block here, is for that block. But the server, which block is the server going to use to check my proof? Yeah, absolutely. The server then gets my proof, so if I'm like walking through this endpoint we just wrote, we can go to like 134, server gets I hit the server with my post request down to line 140, the server gets my proof out, line 143, the server gets the last block, which is Yasira's block. And now we run blockchain of valid proof with Yasira's block in my proof, and I fail. I get nothing. I was mining on a stale block. Very sad. Sad for me. So someone else has already, used this proof, so to speak. So this is what we're setting up here. We're setting up, a situation where we can have, one server and multiple miners. We could have, more miners than this. Down here, we could have, B for Brett. We'd have lots of folks. And the server is, keeping track of how many blocks, is adding blocks to build this chain. Yeah, also a great question, Arpita. So what about line 145? Like, what about doing valid proof? How much work is that? let me state that. Oh, nice. I can scroll and leave my drawings in place. Awesome. Let me put that a different way. What is, if I go up and I'm looking here at valid proof, you know, lines 112, 113, 114. What's the complexity of this? Really, it comes down to what is the complexity of running hashlib SHA-256. Yeah. The server only has to run the hash function once to validate a proof. So that's very, very quick. The hard part is doing the guess and check over and over and over again. The hard part is that proof of work function, which is, you know, running over and over and over. So the miner has to do a lot of work and it's very slow for the miner. The server just takes the proof in the hashed block string, you know, validates it so fast or rejects it. So the server does not have to do very much work. The computer burning all the energy are the miners, and they burn a lot of energy. Like, you know, I'm sure you may have heard of people will buy specialized mining computers and like heat their house with it. There have been people that bought a hut in Siberia, Russia, you know, very cold place, and just heated it with Bitcoin miners. Or they moved to Alaska, you know. So the miners are burning a lot of electricity, generating a lot of heat. And now I don't know how to get rid of these drawings. There we go. Okay. Cool. So that was good. That's a great way to check how all this is fitting together. Okay. So we said before that we only want to actually forge this new block if we have a valid proof. So let's wrap all of that in an if statement. So blockchain.valid proof will return true or false. So we can just make that an if statement. And all of this can get moved over. There we go. Okay. So we got the proof from the client. We made a block string out of the last block. We checked if that was a valid proof with our valid proof function. If that's the case, then we will forge a new block. And so our message can now be, I guess, you know, new block forged. And we can still send the rest of the stuff back. This is how many blocks we are, you know, where we are in the chain, what our index is, transactions, you know, the proof, previous hash. That's just stuff out of the block that we just made. What should we do if it's not a valid proof? Yeah, so we'll return another response, and as Arpita says, our endpoint remains open for someone else to come and hit. So our response, yeah, Brett's got it in one. We're going to return a response saying that this proof is either invalid, if it's a bad proof, you know, you just didn't do it right, sorry, or you know, this is already submitted. In other words, you are on a stale block. So our response can be message proof is invalid or already submitted. Of course, maybe someone submitted a different proof, but that proof also worked. Anyway, the point is you're on a stale block. And we can return JSONify our message. There we go. Cool. Questions on this? What did I say? Oh, you're right. I wrote message. I should write response. Thank you. That's not gonna do right. Okay. Well, let me look at our task list. I think that's pretty much all we wanted to do on the server. So now we should be ready to go and look at our client mining application. So let me go back to there. Let's start on the client mining application. Okay, so we copied and pasted proof of work and valid proof because we do want them for our miner. So this client can, mine on its own. What should I change in here? Well, we already said self, right? That shouldn't be here at all because that only belongs in a class. What else should I change with this proof of work function? I'm just going down and removing the self. I'm going to remove that line entirely. Oh yeah, I'll need a block. That's right. JSON.dumps last block. We've not defined last block, so I'll say we can pass that in. So that can be a parameter. And then valid proof. Looks like, I think valid proof is pretty much good to go. Except we need to change this to a 6, like we did on the server. Okay. So let's see. So create client, let me go back to the task list real quick. So create a client application that will get the last block from the server, run the proof of work function until a valid proof is found, use a copy of valid proof to assist, print messages indicating this is started and finished, modify it to generate proofs with 6 leading zeros. We did that. Oh, thanks, yes, zero. That's right, I only have 5 zeros there. It's one of those things, every once in a while as a programmer, you have like a typo or something, and that can just take, almost longer than any other kind of bug. My gosh. Yes, so on the task list, print a message indicating the success or failure response from the server, add any coins granted to a simple integer total, and so on. Okay, let's see. So here, if you're wondering what this part is, I think this is giving us the ability to pass in a URL on the command line. So in Python, sys.argv will be an array of everything that I've passed in on the terminal. But we're just going to use the default, URL here, so we don't really need to worry about all that. And the same here. This is, Python utilities. It's going to open up. I think that's pretty self-explanatory. Open up whatever is an id.txt, my id.txt. And let me scroll back up to proof of work as requested. So yeah, so now proof of work is going to take a last block because we can no longer get it from the class, and then do everything it was doing before. We're going to stringify that block, and then, whoops, you know what? I missed a self. Look at this. Glad we came up here. We've gotten an error when we ran this. Thank you. Yes, Jordan. Awesome. Glad you spotted that. Yes, so while valid proof, blah, 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 is false. Okay, great. Eagle eyes. Okay. And let's see. So here we're doing requests.get. So again, this is Flask. It's gonna, run this for us. It's gonna go ahead and hit this for us, hit this URL, and we wrap before. This looks pretty similar to what we did in the server file. Request.json. But here we wrap it in a try except in case we get a bad response. So at this point in the file, we've asked the server, we hit the last block endpoint, and we got that. So we have the last block. Whether it's the Genesis block, whether it's something that someone did later. So what should I do here? How can I get that block from the data object? And what should I do with it? So what does data look like? Yeah, y'all have got that. Okay, awesome. I'm going to copy and paste. I'm going to use the data.get because data.get version, because I often forget about how in Python you can do .get. It's the same thing. It's the same thing as the syntax that we're used, that I think I'm more familiar with, like this. Same thing, no difference. Okay, so new proof is proof of work, data.get, last block. Okay. When found, post to the server, done. This is going to go up there and run that loop for us. We don't have to do any while loop or waiting down here. And then we've posted it. So we're going to post it to the server with request.post. And once again, we have this data equals r.json. Yeah, we can make this a little bit more robust. So again, if the server sends us something that is not JSON, then again, we'll crash. Like what if the server doesn't send us back JSON at all? What should we do to handle that? What should we do to ensure we don't crash? Yeah, we can do a try catch, or I guess so we'll do a try except. So we'll try data.r.json. You know what? I'm just going to copy and paste this from here because it's the same thing. Oops. Paste it below. There we go. Right. So we got the last block from the server. Our miner went and mined. We found our proof. We posted it. And then we're looking at the response from our post. So we just wrote, the responses from mine. So we know that this is going to send us either a block of data, which should say new block forged, or it's going to say, you suck, essentially. So, okay, if data message equals new block forged, add 1 to the number of coins mined. I'm going to put that up here and print it. Okay, coins mined plus equals 1, and we can print coins mined. Got it. But in doing that, of course, I haven't made that variable yet. Where should I put this coins mined integer? Yeah, yeah, certainly above the tries and just really anywhere before the loop so it doesn't get reset. I think it doesn't really matter where else we do it. Coins mined equals 0. Because that's before we have started mining. So it is 0 at that point. And if that doesn't work, then we should print the message from the server. Then we'll just print data message. Oops. Tell us what went wrong. Yeah, I think we don't have to cast it to a string, although, oops, we could print a more helpful message. We could do like this. We have mined, like that. It's Python's little, string formatter. So the print function will print whatever. It's just like console log. Okay. Well, that is, let me look at our task list. Let's see, change the name myid.text to your name. I'm going to leave it there. Continue mining until the app is interrupted. That was set up for us. We could add a timer. I'm not going to do that now. Anyone see anything else? Well, keep firing questions. What we can do now is fire up a couple of terminals and see what happens. So I'm going to Python blockchain.py. So we're going to start our server. And okay, looking okay. No errors yet. And I open a new window, open a new terminal, and I'm going to start our miner. So this could be one of the many miners that we're going to start. And hopefully this should start our loop, mine, and then it should hit our server. ID is your name here. That's what I get for not changing that file. And now we wait. That's the one problem with changing the difficulty when we do this. Now that we've made it 6 zeros, you can see how much longer it's going to take. Yeah, coins. Yes, I can definitely go back to the miner.py file. Where would you like me to go in here? So the miner.py is on top, and we have our miner.py terminal running below. Yes, valid proof. Give you an error on 36. Oh, Jordan, that could be because you might be running Python 2.7, and Python 2.7 does not have print formatting statements. Yeah, as Brett says, you can either, if you have Python 3 installed, then you can explicitly run it with Python 3 miner.py. If that still doesn't work, you can confirm which version of Python you have with Python -- version. Oh man, can y'all hear my computer running? My gosh. Hey, look at that. We have mined 1 coins. So success. If I go back to the other terminal, look at this. This is what look at it. We mined 2 coins. So we did get for the last block. And then when we found the coin, we then posted it. And we got back, a successful response. And that's when we printed, we have mined 1 coins. And then we went and got the next block. And then again, we found it and posted it. So we said, we have mined 2 coins. So that whole, the saga of our miner. Okay, we are on the hour. So when we come back, I'm going to probably, let me double check here. I'll go through some little diagrams I found that are nice to illustrate. Yes, I will send both of these files immediately. And then when we come back from our break, we'll go over some nice diagrams, and then we will forge forward, so to speak. And Rain, it's a great question. The mine coins do not get added to the next. Well, I take that back. Mine coins will get added to the next transactions array, or actually to the current transactions array. But anyway, that's what we're going to do in the next hour. So you're right on asking the right questions here. All right, let's take a 10-minute break. Love the energy. Starting a timer. Let me share that. 5, 4, 3, 2, 1, and we have liftoff. Let's dive back in. Okay, I want to show y'all some diagrams real quick. And for the instructor hour tomorrow, also let me know, where am I trying to click on? Try to click on this. Let me know, anything you would like more clarification on, and I will try to, I will make better diagrams if I cannot find any on the interwebs. So let me know. I will create visual depictions of all of this. Okay, so this little diagram. Okay, so far we have not really talked about transactions, which is kind of silly because that's in a way the point of blockchain. And so this little diagram is representing what happens with the transactions. So on the left, we have, Damien is going to give George 500 Bitcoin. So we have to make sure that we keep track that Damien's account goes down by 500, George's goes up by 500. That's what it means to send someone money. We, delete from one, subtract from one, add to the other. And so we have two transactions here, one between Damien and George, and the other between Bernard and Gerald. And all of those get collected in a block. And so we're all pretty familiar with this so far. Then the entire block gets hashed, and that gets included in the next one. And then a new set of transactions will be included in the next block, along with the hash x32 of the previous block. And then that entire block, including those transactions and the previous hash, will get hashed. And that will go on into a new block with a new bunch of transactions. That's the point of a blockchain, is that we can keep track of these transactions in this way. Another way of putting it, again, they're all going. We have the transaction data, we have the signature block, and then we're going to add, this proof in it. The proof is also called a nonce. A nonce just means something that's used once and thrown away. And in this example, we say, the hash needs to start with 7 consecutive zeros. Of course, in what we're doing right now, we're only using 6. So again, all these blocks are chaining together. We know all this. Now, here's an interesting point. Remember how quick it is for our server to check someone's proof. It's super quick. But it's a lot of work to find the proof in the first place. So this is an illustration of what happens if someone wants to send in a fraudulent proof. They're going to need, so the rule is, and I can go into this, I can go more into the why of this later. The rule is that, actually I'll tell you now. Okay, suppose I'm running a server, or we have more than one server running, okay? And those two servers are communicating. It's possible that two miners, send out their proofs, and they hit the servers at slightly different times. So the server is always going to go with the longest chain. So for the attacker to win, the attacker needs to replace the chain starting from, say, block 4 and make a longer chain. And then all the other users will adopt the longer chain. So his goal is to catch up from block 4 all the way to block 7 and pass it, block 8, and say, okay, I've got the longer chain. Everyone use mine now. But it's the proof of work that makes it impossible to do that. It's really hard for, he's going to have to, put out all this effort to hash everything all over again and get up to the front. Okay, I'll come back to the rest of that later. Let's keep going. Unless there's questions on that. No, but so Brett asked, has that ever happened? Has anyone ever managed to, catch up to the front? No, not in Bitcoin so far. This is so for someone to actually successfully go all the way from, in this example, from block 4 all the way to block 7, they would need to have more computing power than everybody else. For that reason, this is called a 51% attack. If I got 51% of the computers, then I could hash faster than all of you, and I could take over. I could go back and change history and then rewrite it and catch up to the front and say, here you go, here's my chain of history. So it's called a 51% attack. Now, theoretically, so everyone is really concerned, could someone get half of the computing power? And in Bitcoin, there's actually surprisingly few people controlling a lot of the network. So it could happen. On the other hand, if someone managed to do this, then no one would trust this chain anymore, because they say, hey, look, just one person is controlling this. You can rewrite history anytime you want. You can take all the money. We don't want to use this coin anymore. And so even if someone did take over, they wouldn't be rich for very long. Nice. Right. With that said, let's add transactions. We should add some sort of simple form of transactions to our blockchain. So this is what we're going to do now. We're going to add basic transactions. Here are our instructions. Just some basic transactions guided project. Create a method in the blockchain class called new transaction that adds a new transaction to the list of transactions. And so it's going to take a sender, a recipient, an amount. It's going to take those parameters, and it's going to return the index of the block that will hold this transaction. So let's go to the editor. Here we are. It's our miner. Let's go to our server. I'm thinking server. Blockchain. Right. So as a review, so remember we had this current transactions list right here, but we didn't really do anything with it. We still haven't done anything with it. The only thing we did is when we create a new block, we put transactions self.current transactions, and then we reset it. So why do we reset that? Why do we reset the list of current transactions on line 48? Yeah, the new block will have new transactions, and we want a clean slate for the next block. If we collected, so we had a bunch of transactions, but we've already included them in this block. They're safely stored here. And so we can reset it. We can reset those current transactions. Let's scroll down and add as directed. We want to add a new transaction method. We want to add new transaction. And I'm going to paste our instructions here. So that looks like the rest of them. So we want param sender, param recipient, and amount. There's sender, recipient, and amount. And we'll save a transaction in a dictionary. So the sender is just going to be sender. Nothing too complicated here. Oops. Let me do this. Let me try doing this correctly. And recipient. Right? So there's our transaction. What should we do with this? How should we add it? We want it to go in the next block, right? What should we do with this transaction now to ensure that it is included in the next block? Yeah, we want to add it to the current transactions list. So we can do self dot current transactions dot append transaction. And we want to return the index of the block that's going to hold this transaction. So which block will hold this transaction? Yeah, the next block. Yeah, so not the, so if our chain, has a whole bunch of blocks in it, suppose that's our chain, right? And there's our Genesis block, and we have some other blocks, block, etc. We want these transactions to go not in this block. Okay, I'll do one more. This is our last block. We don't want the transactions to go here. We want these are going to go in the block after that. It's going to be made. So its index is, well, one more than whatever this last block is. And Rain, I'm going to come back to your question in a second. That's a good question. So what can I use to get this index here? Index equals, remembering that we're doing our index, our indexes here are one indexed. Yeah, we do len self dot chain, but actually, because this is, we remember if I go up, I'll remind you, where is that? Here we are. For each block, we say its index is self.chain plus 1. So the Genesis block, its index is 1. The second block, its index is 2, 3. So we need this to be len self.chain plus 1. Because annoyingly, we have one index this. Okay, now we have a method that we can use to add a new transaction so that on the next block, these transactions can be included in the block. Well, let's see, the next item on our list says, or our task list, modify the mine endpoint to create a reward via a new transaction for mining a block. Okay, so I come down to mine. And so the idea here is whoever did, doing this proof of work, like we discussed, is a lot of work. It burns electricity. It's really expensive, actually. Again, people are like deliberately moving to areas where there's cheap electricity so they can run their computers to do all of this hashing. It's kind of crazy. And as a reward, so, why are people going to do all this? Well, we're going to pay them to do it. So when should we pay someone? So whoever has won the contest is going to get a coin. When should we give them a coin? When do you get paid? In 2 weeks, I get paid on payday. Yeah, essentially when their block is added. So if we check that there is a valid proof, then we know there's a valid proof. Now we're ready to add a new transaction. But we want to make sure that this is included in the new block, because we want you to get paid as soon as possible. So we'll do a new transaction, and our task list says to have the sender be 0. So usually we'll have the sender would be somebody's ID. But here the sender is 0. Say that the chain itself has awarded this to you. And recipient is the miner ID. Whoever successfully did this, and you get 1 coin. So we just added a new transaction. So our current transactions now has this transaction in it. And then we immediately go and make the new block. And so the new block now includes that transaction in it. Oh. So I think hopefully this now will start to answer Rain's question. What happens with a new transaction? So the new transaction by itself won't make the miners start from scratch. But then in a second, at least in this case, we're going to add a new block. And now, yeah, totally, the miners have to start from scratch. Questions on that? These are all great questions. These are good questions. So I will take Yasira's question first. So there's no limit on how many transactions we can have. I'm going to jump all the way up. Okay, here we're at the top of our blockchain file. So in our current transactions, right now we're giving an example of a transaction where the sender is going to be 0 because we're awarding someone who's mined a coin. So the recipient will be the miner ID, and then the amount will be 1. But we could also, and I'm going to show you an example, and I'm going to walk through this in more detail in a little bit. we could say the sender is Arpita. Recipient. And the amount is 1. So there's no limit on how many transactions we can have. Because however many transactions we have, they are all just going to get included in the block down here. They're going to get included in self.current transactions, and then we will reset them. So this is kind of cool, actually, that you can include however much data you want, because it's very simple text, doesn't take up a lot of space, and then it's going to get hashed. And the blockchain will, memorialize the data you've put into it. Yeah. Looks like I'm creating IOUs with my examples here. Right. I see what I think I see your question here, Rain. This is a good question. Let me think how to put that. Okay, I'm gonna do it. I'm gonna do it like this. Right. Okay. So once again, so we have our server here. This is me. I'm mining. Rain, you're mining. And so the server, we start off with a Genesis block, which has, of course, no transactions at all. It's a very boring block. And so we start mining, and Rain wins the first round. So she sends her proof in. And as we saw just, let me finish doing a little thing before I scroll anywhere else. So there's your block. But to make that block, as we saw down here, you send in your going down, going down, going down. Where are we? Here we are. Here we are. So on line 166, we make a new transaction that's going to reward you, and that goes into your block. So your block here with the R includes that transaction. And now let's say, getting back there we are, getting back my annotation. So now here we are back hard at work. We're both trying to win this contest, and you pay me. You decide to give me, you give me your coin. So that goes in our list of transactions. At that time, our list of transactions just includes, you sending me 1 coin. That's you sending me 1 coin. I apologize for how dreadful that writing is. And whoever wins this, suppose you win again, now the server will then add that will add the, it's going to send 0 to Rain. It's going to send 1 coin. So our list includes both of those. And both of those go into this next block here. So when we add a transaction in the middle while we are mining, it doesn't upset anything. It doesn't change anything because we are both still looking at this block here. So we can add to the list of current transactions without having to restart. We're still both looking at the old block. And those new transactions go into the next block that is added right after we find the proof for that previous block.
So Tim, can I repeat what I think I heard you say? The only time a block is actually created is when a coin is mined. If in between finding a coin or mining a coin, transactions are made. Let's say I have a Bitcoin and I buy something from somebody and I want to sell, and then I give them that coin. It doesn't create a new block with that transaction. That transaction goes into the current transactions array of the last block, and it just adds on to the current transactions array. Is that correct?
Yeah, yeah. So exactly right. So we have this last block here that we're all working off of. And then independently, we have this current transactions array that's waiting to go into the next block. So we can add to this array / list as much as we want without messing anything up. And then as soon as one of us, in this case, Rain again, finds the proof, then we're ready to forge a new block, and that will include all of those transactions. Those are going to be in this block here.
And so in effect, Rain is right in that as new transactions get added to the current transactions array, that will necessarily change the value of the hash that you're looking for, because that transactions array will result in a different value because the object has changed. So everyone kind of starts over again every time a transaction is made.
No.
Okay.
No. Because we are, if I can get back to my drawing tool, we are working with this hash here. We're working the hash of this block, right? So let me delete that one. Delete you too. Go away. Little R. Right. We're working with this one, right? We're hashing that. And independently of that hash, independently of our proof of work working away on the hash of this block here, we have this array, this list, which can grow to as many transactions as we want. So we can add to this transactions array without changing the hash of this block, which is what we are using to hash. Does that make sense?
I think we are confused. One thing I want to ask, is the hashing is independent of the current transactions, the number of current transactions? Suppose I'm mining a block, and during my mining, a lot of transactions are taking place, but I'm not much aware of that. Will my hashing be interrupted with that, or will have any problem, or it is not affected at all?
It won't affect it at all, because your miner is using the hash of this block. And then independently, the server is collecting this array here. So after you then send your proof back to the server, then we're ready to use that proof. So we come back here, there's our proof coming back in, P for proof. And we're going to use that to make a new block. And that block includes this array. So we use that to make a new block, but we were running the contest with the block here. So at the time we were running the contest, at the time we were hashing, we were using the last block, which was this block here.
Right. I think I'm clear on that.
Cool.
Thank you.
Yeah. And I have one more little example that I will go over in a few minutes that may help as well. Yeah, that's right, Rain. That's a good way of putting it. The last block is locked. The last block is and my miner asked for that last block, and then we, as you know, we're going to use the string of it to keep looking for our hash. The new transactions are just floating. The server is keeping track of them, waiting for a new block.
So the server blockchain self.current transactions, that array is fluid, and that's keeping track of all the transactions that have happened since the last block happened. And then where the next block is found, then those current transactions that the server is keeping track of, that goes into the hash of the next block.
Totally. Yeah.
Thank you.
And you can see that here because we first we say, okay, look, we've got a valid proof. And then we add the new transaction, but we have not yet made the new block. And then once we've changed our transactions, now we come over and we're like, okay, let's make a new block. And so that block includes the transaction we just added here. So it's like right before we go ahead and make a new block, we're like, hey, let's change our transactions array, our transactions list. Awesome. Awesome. Well, let's keep going down this road. The next item on our list is to create an endpoint at transaction/new that accepts a JSON post. So we're going to allow anyone to hit our server and add to our transactions array. So let's do that. We're going to make a route. Methods equals post. Def, I guess, new transaction. I guess I'm naming it the same as the class method. The class method is safely protected, but I don't know. It's a little annoying to name it the same thing. I should probably name it something else. If y'all think of a good name, we want to add a new transaction. So as we have done before, we're essentially, let me see. In fact, I can open up our miner file. Oop. Does that make that hard to read? If we scroll down, we can see what we want to do here. We need to do the get JSON. Where's that? No, I'm thinking of something. I'm thinking of a different location. Whatever. I'm making this big again. Data equals request.getJSON. Yeah, values equals request.json. And we should check that. So we're going to need sender, recipient, amount, because of course we're going to want to put that in our blockchain in a second. And we can do what we did above, basically. There's a shorter way of checking that all of these are present. So if we want to do basically what we did up here, right? We want to make sure that we have all these properties. There's a shorter, more Pythonic way of doing it, but I'm going to do it this way because I like to be super obvious. So if sender not in data or recipient in data, or what's the last thing? Amount, of course, not in data, then again, I guess we should say response equals message, required properties not included. And then we'll return JSONify our response with, say, a 400. So a Pythonic way, let me see if I can remember this. It's something like this. You could say required properties is like an array with sender, recipient, and data. And then you can say, if not, so all is a function that will take something you can iterate over like this, and it's going to return, oops, not that, just plain true. If they're all true, then all will say true. If it has one false in it, all will say false. So you can do, I want to say k in required properties, or k in, I think it's k in data for k in acquired properties. That's a more Pythonic way of doing it. It's going to say for, I think it's actually fairly easy to read, a little weird at first. So for every key that we have in required properties, it's just saying there's definitely a key in the data. Awesome. Jordan thinks I've got it right. That's good to know. So that's a somewhat more Pythonic way. So I don't have to keep writing out tons of these. And obviously, if I had 6 required properties, then line 2 of 3 would just be unworkable. That gets ridiculous. Right. What should I do with this now? We have sender, we have recipient, we have data. What should we do? What's the point of this method? Or endpoint, I should say. Yeah, we want to do blockchain dot new transaction with, I'm going to pull these out. Sender equals data sender. Recipient equals data recipient. And amount equals data amount. Voila. And then finally, we want to return the index of the block containing the transaction. Oh yeah, but that's right. But if we go back up and look at our method here, new transaction returns the index. So we can get the index from there. I'm going to jump down to the end. So index equals that. And then we can return a nice little message. As always, response equals message. I'll say block index like that. Like that. Return JSONify response with a 200. Actually, 200 isn't quite right. 200 just means we successfully received your request. 201 means we created, yeah, thanks, Jordan. Boom. 201 means we created a resource in response to your request. Okay, so now anyone can add a transaction, which is obviously, just allowing anyone to create a transaction. I could write a transaction. I could say, whatever, Rain and Yasira give me all their money. Awesome. Good for me. Because anyone could, at this point, can send in, anything with any sender, any recipient, any data. Oh, I shouldn't have data here. I just saw that. It should be amount. Yeah. So this is completely insecure. Real blockchains, need to. Oh, thanks for noticing that. Real blockchains add a lot more checks to ensure that whoever is right here, yes, that's not going to work without that. As soon as I start this up, it would throw an error. Then, in real blockchain, we have to create a transaction. You need to prove that you are in fact authorizing this to depart your account and go to someone else's account. So this is like completely insecure. But for demonstration purposes, this is how this works. Yes, I could Let me fire this up real quick. Okay, so here's terminal 1. So I won't bother to hit the endpoint that we just wrote now. Aha. Oh, this is, it's complaining because I left my little demonstration in the code. Let me jump up. Where is that? That's here. Remember I wrote this chunk in here. It's really just complaining because I didn't write the dictionary in the correct Python way. Okay, let's try starting the server again. Hey, the server seems to be running. And let me change this to the other terminal. So here is the miner. Start the miner. Oh no. Oh wait, I didn't successfully start the blockchain. That's why the miners quit. Okay, everything appears to be running. And I think what should happen, is now when we mine, we should see that the server adds a transaction to reward us. So when we get a coin, if we go and look at the chain, we should see in the transactions list of that block that we just mined. See that we mined a coin. So now if we go and look at localhost, we should see, if we look at the chain, we should see that we've gotten a coin. Awesome. Let me share. There we are, finding the right one to share there. Let me see. Localhost 5000 chain. What do we got here? Look, so there's our Genesis block. And then second, here's our second one, index 2. And here we are. We have this transactions added, amount 1, recipient, your name here, sender 0. So that worked. We are being rewarded for our hard work mining. Let me stop my server, my terminal, so that my computer stops making a jet sound. Right. I want to talk you through this quick chain example, and then we will be pretty much done. Okay, so what we're going to do, so your project for tonight is to find someone's account balances, for tonight and in the next couple of days, is to find someone's account balance. But you'll notice we haven't stored someone's account balance. We haven't just said, okay, hey, Tim has this much money. That's not stored in the blockchain. Instead, we figure it out. We know that all the coins in existence were awarded by mining. So we can see who got them originally and then where they went from there. And by doing that, we find out, you can then see how much money someone has got. So check out this example. So the first one, here's our first block, it's our Genesis block. Now we could have used this block because we're the ones writing this blockchain. We could give ourselves, 1 billion Lambda coins. But people, might not trust us very much after that. And no one would use our chain. So we did not give ourselves any money. But here I'm using, Christian is going to be my example here. So he gets a coin. He wins the race. And as a result, we put him in this transactions array. He gets 1. And he wins the next race. And he just can't stop winning. This is crazy. So obviously he's now won 3 in a row. So he has 3 coins. Those are all the coins in existence. There are no other coins. So in between, so we hash this block and we send that out, right? And now Christian and say Yasira are both mining. while they are mining, Christian sends money to Yasira. He gives all of his money to Yasira. Then he wins again. And as a result, the transactions array contains both of these two transactions. Now, of course, if we looked at people's account balances right now, Christian would have 1 and Yasira would have 3. So now Christian and Yasira and let's say Rain and Reed and Brett are all out there mining. They're all out there mining. Let me annotate this. We have our server, and here we have, let's say, Christian, we have Yasira, we have Rain, we have, oh no, I'm messing up, Brett, we have Reed. So they're all mining. They're all mining. And so in which block are they mining? Which block has been hashed? Which one are they looking at this point? Yeah, exactly right. Exactly right. Everyone is working off of this block here. We're all working off of this. We have index 5. That's what we're working off of. I'm going to erase that because that's like really poorly drawn. But that's what we're looking at. And so while we're all working on that, then Yasira decides to give a bunch of money to everybody else. So she gives half a coin. She gives half a coin to the other 3. She's like, hey, welcome to the party. Maybe she wants to encourage everyone to use the blockchain, make them part of the community. So she sends in that transaction. And then once again, though, Christian wins again. So he's going to get 1. And the transaction that, Yasira had put that into the current transactions array. And so that is also included in this new block. And now everyone is working on block 6. So that's how that works. And to find out everyone's current balance, you're going to need to go through the entire chain and look at, so say I want to know how much money Christian has got. I've got to look at every transaction and say, is Christian a recipient or a sender? And either way, I have to, credit or debit his account correctly. I have to subtract or subtract. Likewise, say with Reed, I have to go through and, I'm looking at all these transactions and, Reed's not here, Reed's not here, Reed's not here. I come down, up, okay, Reed's a recipient. Okay, plus 0.5 to his account. So everyone starts at 0, and then they're only going to, get as much money as they either mine or are given. This is also why blockchain is not as anonymous as people sometimes think it is. It has this reputation for being used for really shady transactions. And it is, to be fair, but it's just not as anonymous as people think it is. Because the way you find out, the way you give people money is by writing it into history in this way. Yeah, so your project for today is to write a simple front-end program that can query the server for the full chain and then use that to display the current balance for a given user. Miguel asks, in real life, are the coins mined Bitcoins? Yes, for the Bitcoin blockchain. Bitcoin was the first one that worked. And to this day, no one knows who Satoshi Nakamoto is. Satoshi Nakamoto published a paper talking about how to do Bitcoin. And then he actually went ahead and set it up. He, she, it, they, who knows? The entity known as Satoshi. But there are many other blockchains. Ethereum is, I think, the next most popular, and it's pretty cool. You can use the blockchain to program things, which is kind of wild. So there's lots of other altcoins. Most of them are junk. To be fair, most of them are junk. There's many other ideas, you know, as I say, blockchain, just such a rabbit hole. Many other ideas have come out of this, which is kind of fun. I will post this article for y'all because public key cryptography is a really important part of blockchain. And this is still the best article I've read that gives you a really good intuition for how public key cryptography works. I think that's about it. Final questions before we go. I'm going to post the updated files for y'all, of course. All right. Thank you all very much. Best of luck with the next part of this. Well done getting your coins mined. This is always fun. All right. Have a good night, everyone.